Hi all. So we can start our second chapter, Digital Computer Fundamentals. Digital Computer Fundamentals. Introduction. Everything is digitizing today, like text to video, papers to disk, man to machines, etc. So this is the type of sophisticated system today we are having. Then digitization describes that any word matter can be represented in the computer as digital data. Yes, obviously we can represent all the things, all the matters with a digital data or digital content. Digital data is nothing but zeros and ones. So we can represent the datas, every kind of datas with only using two numbers, that is zeros and ones or binary bits. This is also known as machine code. Zeros and ones are known as binary bits, which is used as machine language, and components of a computer used to represent the data in zeros and ones. Zeros and ones. Digital computer is capable of representing different values like text, images, audio, and video informations. Example for digital computers are PCs, desktop, laptop, smartphone, tablet, calculator, ATM, digital clock, etc. Next is fundamental knowledge. A computer program is a collection of instructions that can be executed by a computer which is written by any programming language. Today we have a lot of languages in programming language category. We can choose any of that languages to maintain these everything. Computers can do any task which has been programmed to do some action. What are the actions? Whatever you are doing in computer is known as the actions performing in a computer. Then programs are specified and stored in the computer. Whatever you are doing, it will stored in your computer in anyhow. Computers cannot do anything without the instruction from the user. So computer cannot think, cannot do anything individually. It will guided by the human, by us. Then various types of computers are developed from the time to time. In the previous years, we know that a computer means an entire room. An entire room need to place a computer. But today it is changed, like we can hold that system inside our pocket itself. The evolution from large sized system or a simple calculating machine to a smaller but much more powerful machines is designed as the generations of computer. So everything you know, what are the generations of computer and all the things you know, then each generation is based on the technical development characteristics and all. Something will be in some kind of technicality, something will be different in its characteristics, something will be different in features and all. So these all are the fundamental changes in our computer evolution or generation. And integrated circuits are the basic building blocks of the digital computer. Logic, gates and integrated circuits are very familiar word to us. So integrated circuits are the basic building blocks of digital computer. Integrated circuits are also known as IC, chip, microchip and all. Then IC is a set of electronic circuits or logic gates on one small plate of semiconductors material, normally silicon. Logic gates are elementary or fundamental building blocks of digital logic circuit, which is used to perform basic logical functions. So we can do all the basic logical functions with the help of logic gates. We will learn all the logic gates in the coming parts. Then operations of ICs are controlled by various logic gates embedded on the circuit. So all the logic gates will be embedded in our system itself. Number of logic gates for ICs can be vary accordingly. So in each and every system, the number of ICs can vary accordingly. It is not compulsory to keep this much number in a system. We can vary the number of ICs with accordance our needs. Then by combining more logic gates, highly complex operations can be performed its functions. So whatever the function is it complex, is it simple, is it a medium type, whatever it is, we can fix it with the help of the logic gates. Then ICs are used in electronic equipments like computers, mobile phones and other digital home appliances. So let's have a look what is the logic gate classification actually. You can see on my screen logic gates. We are classifying it to three categories. One is basic logic gates, second one is universal logic gates, third one is other logic gates or special purpose logic gate. So what do you mean by basic logic gate? Basic logic gate means by using the category basic logic gates, you can make all other logic gates. So this is the basic idea or base logic gate. With the use of these basic logic gate, you can form any other logic gate without any issue. Then the next one is universal logic gates. Universal logic gates. In the category universal logic gates, you just need to use the universal logic gates to make any logic gate. Simply you just need a simple universal logic gate and some other symbols only. Then special purpose logic gates. So let us see what are the applications available there. Basic logic gates give you three options. First one and, then not, then or. Then second category is universal logic gates. You can get the options like NAND, NOR. And special purpose or other gates will give you the facility XOR or XOR. Both you can call XOR or XOR. Then XNOR or XNOR. Then we have the definition for universal gates here. The NAND gate and NOR gates are known as universal gates as these can use to implement any Boolean expression. That is, any Boolean expression can be implemented using NAND gate alone or NOR gate alone. We need not use any other gate for the implementation of expression. I think you got the idea. So we don't need to use any kind of expression to form any other gates. Simply we need to use these universal gates like a NAND or NOR. Then logic gate symbols. Mainly distinctive shape will be there. Then rectangular shape will be used for representing the logic gates and also shows the operating procedures of the logic gates that we will go to the next slide. We will get all the ideas from there. So you can see one more point is there, that is truth table. Used to understand the behavior of logic gates. How can we understand the behavior of a logic gate using truth table? Do you have any idea? Yeah. Actually, we are seeing the values 1 and 0s in that truth table. It will guide us that how it is working. Is it in on stage or off stage? Everything will be conveyed using the truth table. So, it shows the relation between input and output. We can have the first gate here and you can see the diagram shown here. The first one is distinctive shape. Then you can see the rectangle shape and also the operating procedure you can see here. So in the first diagram, two inputs are passing to AND gate and you are getting the output A and B. A and B. This AB can be called as A and B. Then you can see a rectangle symbol is also placed here. Two inputs are going to that rectangle and one output is coming from that, and you can see that can be also denoted as A dot B. A dot B. Then you can see the circle marks which is indicating that what is the operation behind the AND gate, and you can see the inputs provided using two pins A and B. When A is 0 and B is 0, then output will be 0. How it is 0? A into A, 0 into 0 will give you the result 0 itself. Then in the next A 0, B 1. Then what will be the output? If you are multiplying any value with a 0, then your value will be remain 0 itself. So again we are getting the answer 0. Then in the next point A will be 1, B will be 0. Again we are getting 0 because 1 into 0 will give you the result 0. Then in the next condition A is 1 and B 1. Then 1 into 1 will give you the answer 1 itself. So the output is 1 in AND gate whenever we are giving two ones as input. Clear? Then you can see the next gate is OR gate. In the OR gate you can see the symbol is just like this. Here I am passing two inputs A and B. Then what is the output? That will be A plus B. A or B means A plus B. And what is the rectangle symbol we can get here? You can see that two pins are going inside that rectangle symbol. One output is coming from that box. And what is the condition checking here actually is the value is greater than or equal to 1 or not. That is the condition checking taking place here. Then what is the output? A plus B. A plus B. Just look at the inputs and outputs. You can see the operating procedures here. A is 0, B is 0. Then 0 plus 0, 0. Then output is 0 here. A and B. Just look at the second values. A is 0, B 1. 0 plus 1 is 1. Then A is 1, B is 0. 1 plus 0, again 1. Then A is 1, B is 1. 1 plus 1 will give you the result 1, 0. Then we can get that value 1 itself there. So this is the diagram used for OR. Then the next basic gate is NOT gate or inverter gate. NOT or inverter. In electronics, a NOT gate is more commonly called an inverter. The circle on the symbol is called a bubble. You can see after that triangle, you can see a bubble there. Then and is generally used in circuit diagram to show or indicate an inverted input or output is placed there. So simply you have to understand, however you can see a bubble means it is a NOT or inverted one. A is passing as input to a symbol and that symbol is NOT here or inverter here. Then you can get the output A complement, A NOT or A dash. These three things are giving you the common idea. A complement, A NOT, A dash, everything is same. Then if we can see that bubble with the A, that means you are inverting A there, that will just opposite of A. Just opposite of A. Then you can see the rectangle symbol here. In the rectangle symbol also we have the bubble there, that means it is inverted. Then you can see the operating procedure there. In that operating procedure, two rings are there. Then A, input A, we are passing two values. Possible values are two. One will be 0, one will be 1. Then if we are passing the input 0, then our output will be just opposite of 0, that is 1. And if we are passing the input 1, then our output will be 0.